The title of the session you can see on the screen, Gain Insight into a Release Pipeline Model. We were talking this week that we probably should rename it in the future to something like, profound impact on your organization using hashtag PowerShell DSC on hashtag Windows Server or hashtag Cloud or hashtag Azure, to just include a whole lot more buzzwords. We were pretty conservative with our title. The gist of the session, just in case, if you say this is not what I'm into, so you need to go to a different session, I understand. The gist of the session, if you saw in the keynote, Donovan Brown talked about using a release pipeline, in other words, using the skills and the tools that developers often use for how they release applications. We're going to go through what it looks like to use that same process and use that same skill set and tool set for managing core infrastructure. So if you're looking at things like DSC and Chef and Puppet, and you've built your career developing a skill set managing Microsoft technologies like Windows Server, and you're even thinking beyond, so what's this going to look like when I introduce containers and I introduce Azure Stack, and people expect me to build ARM templates and things like that? How can I start thinking about this as it applies to the world in front of me right now, where I've got applications that aren't immutable, they have state, and I have to think about how I can incrementally deploy changes to them. And this new world of DevOps and agile tool sets and all this stuff is getting talked about. What does that even mean to me as an infrastructure specialist in the Microsoft landscape? That's what we're going to cover. And we're going to talk about where to get more information, and we're going to walk through an end-to-end demo that demonstrates what that looks like. So if that's the topic you're interested in, you are in the right place. My name is Michael Green. I'm a program manager on the ECG CAT team, which is Customer Architectures and Technologies. So if you've participated in a TAP program, if you've joined one of the feedback sessions, our job is across Azure Stack, across OMS, in this case PowerShell, across Windows Server, is to find out what would customers like us to include in our planning process. What's their feedback? And before we go live with the next version, let's make sure that we've followed up with those customers and made sure that we're delivering on the things that they need most. And as we continue to move faster and faster and faster, that becomes just even more important than it ever has been before. So it's a really fun place to be right now.
And I'm Mark Gray. I'm a program manager on the PowerShell team. I'm the PM owner for desired state configuration. Prior to that, I worked on group policy, so I've been in the management space for quite a while, and before that I worked at a startup that did group policy stuff. And what I'm really excited about this session, Michael and I have been working together quite a while on this kind of stuff, is just the change that this is introducing into the industry and how much faster and quicker you can get things done. So I'm really excited to talk to you about this stuff and show this stuff to you. And we do have we'll have a couple of questions throughout the presentation. And I don't know if you guys can either see or are aware of these things, but the unicorn Microsoft sticker here, and what is this? Some sort of dinosaur sticker.
It's a cat riding a dinosaur.
We have a few of these
normal
stickers to give out for.
Yes.
That's not a cat, that's a dinosaur.
Oh, there's a cat on its back with a flag.
Oh, okay. Gotcha. So we have a few of those to give away to people anyway.
Make sure this thing advances correctly. Change our view, maybe. So there's questions about, like I mentioned earlier, yeah, we get how things like ARM templates apply to Azure, and in the future, things like Azure Stack. So I'm going to declare my infrastructure. So I'm going to take all the complexities of working across a whole bunch of different interfaces, which we'll talk about in a second, and declare that into a JSON file in that case. I want storage, I want networking, I'm going to need a server, I want to configure that server, etc. So we kind of get how to do that in a full-on cloud environment. One of the things we want to cover today, if you're looking at the screen here, how does that apply to Server 2016 directly? So maybe you're not ready to implement an API-based infrastructure. You want to know how to use scripting as a model to implement declarative configuration against Windows Server, that you can start working with right now. So last spring, we announced this at PowerShell Summit. I co-authored a white paper with Stephen Morawski from Chef Software. He's also a PowerShell MVP, very knowledgeable guy about these types of processes. And just like the session title, it's the release pipeline for managing Windows Server in the Microsoft Cloud. It's about 50 pages. Go ahead and download it right now. We'll give you a second to read it, and then we'll all go over it together. No, it's it tries to go over this same topic, so we're gonna breeze through the subject today. But if you want more information, if you want to dig in and kind of explore how would I do testing on my workstation, how does this kind of translate in the future as I start incorporating more cloud APIs in my infrastructure, this is a good resource to dig into as a follow-up to this session. So I want to start off with how do we think about digesting this information? A friend of mine gave me this book. I'm actually just going to build out the slide. The Structure of Scientific Revolutions by Thomas Kuhn. And it hit me as this is perfectly aligned with the thing that we're trying to cover whenever I understood why he gave this to me. I'll save you, he ruined it for me, so he told me the point and then I didn't go read it. I just confirmed that he wasn't lying and said I'm going to borrow the point. But it's basically, there's two things that have to happen for something to be a revolution. The first is it has to solve a bunch of new problems. So what does that mean to us? You're staring at all kinds of changes as far as how are we going to manage our infrastructure going forward. So as things become more private cloud-like, that's going to change the skill set, that's going to change the tools, what does that mean for us? And as you start playing with those tools, you find, wow, this actually would allow me to bend all the rules that I knew previously, so now I can move faster and I can hopefully deliver more value to the business. So you have this new paradigm coming at us. The other thing that has to happen for it to become a revolution, so how do we know this is not just a fad that we're going to move on and in 5 years there'll be something else and we don't even think about that anymore. So how do we know it's going to stick? Is that it also has to be better at solving all the old problems than the tools we had before. And that's whenever something shifts from being just a one-time, oh, that's interesting, to, oh, wow, this is probably something that's going to stick for a long time. So that's what I recognized whenever I was kind of working through this as, I do think we're seeing that. We're seeing this new concept of private cloud and public cloud come into our lives, and then a lot of people are playing with those tools and saying, if I could apply these principles to my existing infrastructure, that would be fantastic. I just have to figure out how to do it. A lot of the concepts in the white paper are based on, let me just say this, there's almost no original thoughts in the white paper. What we did is go stand on the shoulders of people who have put out lots and lots of content already. And all these books are great, and if you go to that URL, that's Stephen Morawski's list for books that he's found to be interesting. It's what I go to whenever I'm ready to pick up a new book. And there's several in here that directly are referenced in the white paper and directly influenced it. But these are lots of good resources where if you want to go much, much, much deeper into any one of these subjects, they're excellent references. I'll let you work through this one.
So we'll be talking about practices today with the CI/CD pipeline that apply to all customers throughout the spectrum. Customers that are already doing DevOps and embracing it and ready to go, they have approval or have their management saying, yes, let's do this, we see what the value is in this, and there are other customers that are not embracing DevOps yet. There's still practices in here that can be used by those folks. Source control is one of them. Just taking little bits here and there can allow you to get a ton of value out of the process itself. So.
Yeah, and Mark and I meet with a lot of customers, and we see both sides of the spectrum almost every day. We'll meet with somebody who's on the cutting edge, and they're teaching us, this is where the information comes from for this kind of a session. And then the same day, we'll go meet with somebody and say, "You'll never believe what we heard earlier. Are you guys doing anything like this?" And they'll say, "I don't know what you're talking about. That doesn't sound like anything that we're doing." And that's fine. That means that the industry is in a state of identifying new processes and trying them out. So we'll all end up in sort of the middle of the wave together. One of the things that I keep finding, and I had thought about writing another white paper, which is how do you get out of an outage without randomizing a server? And I started looking at, okay, well, what are the practices? And the content on this slide just smacked me in the face as we already know the answer to this. If you think about the services available today in public clouds. So let's start at the bottom and work our way up. With software as a service, you're a consumer of the service. So think about something like O365. You have an email account. As an admin of that service, you can provision mailboxes and make changes to them, but you're not actually running or provisioning the mailboxes as code that you're putting on the service, right? You're just consuming that service. It's all laid out for you. You interact with it as an administrator or as a consumer. If you go up one level higher and think about platform as a service, that's something like SQL Azure. So there you are actually going to build the solution. You're going to build out what that database is going to look like, and then you're going to put it on a public cloud or put it on a private cloud. But you're not running the server underneath it. You're building the solution and putting it on a service that hosts that solution. And then move up the next tier to infrastructure as a service. And that's where you're provisioning virtual machines onto a cloud or moving virtual machines to a cloud. And you've all probably lived the same experience that I've lived, which is I built out my first Azure virtual machine and I immediately remote desktop into it. Holy cow, it's actually a server running somewhere else. Like for some reason I thought it wasn't going to be a server whenever I connected to it. And I don't want to overemphasize like, oh, you shouldn't use remote desktop. It's not the tool of using a GUI, because I can randomize a server using the command line all day long. I can break that server from the command line. I've done it many, many times. So it's not about the tools, it's about the process. The process, when we were using Platform as a service, if I wanted to provision a website, I developed the website and I published it. If I want to make changes to that website because it was broken, I went back, I fixed it on my workstation, I tested it, I made sure it was right, and then I provisioned the change. And I never went to that underlying service and randomized it. If the people who were running it for me, even if it was a regional service provider, if I knew they were logging onto the server every day and saying, well, the way that we usually deal with someone publishing a best practice for security is we open Regedit and we change this from 1 to 0, and hopefully I navigated to the right place and didn't make a mistake, and then if it doesn't fall over, then I'm sure it's fine. We would not use that service provider because we would say, hey man, you can't just randomize the place where my stuff's being hosted and cause outages, but we do it to ourselves over and over again. So I think, how do we get out of an outage? We need to start thinking about what are the procedures we're using in PaaS that we can learn from and then apply those towards the IaaS environments that we're hosting. Actually, if you want to speak to this one, that'd be great. We'll take it back and forth. Want me to take it?
Yes, you go for it. I haven't even.
I wrote this slide, so I'm going to get it in mind what I want to say here. So whenever we say configuration as code, what do we mean? And why does it matter? And so I just want to make sure that we scope this as to what we're actually talking about. Because we started off talking about DSC and ARM. What we're really saying here is, as infrastructure specialists, especially if you're into scripting or some level of automation, you have witnessed that everything is different. So why would we want to develop PowerShell DSC? Well, just look at Windows. The way that you interact with the registry versus the file system versus Active Directory versus IIS versus DNS versus every single part as we go through and try to decide how to make a change is different. Moving to a declarative configuration means that you can, in this case, use DSC, desired state configuration, where the experts come along and write a module that says, this will build and configure DNS. This will build and configure Active Directory, and it surfaces as a configuration that looks like an answer file. So now everything starts to look consistent as you go from interface to interface. There's actually partners who have built out DSC configuration or DSC resources and configurations for managing hardware. They say maybe you want in one script to provision the server hardware the way that it's supposed to be, and then the software on top of it. It's not that everybody's playing favorites with DSC or anything like that. The idea is, let's get to a consistent approach where I can go to source control and just not have to worry that everything's different. Define it consistently. And our partners in Chef and Puppet are following the same lines. If you look at the way that you configure Azure using ARM templates, it follows that same type of thinking. The last point I want to make on this is, and we'll talk about this again, but this becomes your living documentation. So now that you've got that as that consistent, here's a file that describes exactly how this is supposed to look, you no longer have to go create the Word document that says this is how I built the server. That is the document that says how you built the server, and every change you make means that you updated your documentation as well. So when you think about configuration as code, just think about it as that living document.
So the release pipeline that we'll talk about today, we've broken it up into kind of 4 different areas that we'll kind of focus on, and I will talk to this side of the room because Michael is focusing on that side of the room. So we've broken it up into source control, build, testing, and release. These are kind of the general areas that we'll discuss and give you high points on them. It's kind of the flow, kind of in general, how you go through the release pipeline, but the test and release and build, there's some iteration that goes through there that we'll show you in our demos. But essentially, these are the big buckets that we'll talk about in the process. So we'll start off in source, and source control, like I mentioned earlier, is one of the places where, if nothing else, start using source control for managing your, even if you're using PowerShell code itself, use source control to check in so everybody knows. You have a central location for seeing where the scripts are, what the changes are, and things like that. And one of the biggest things that you get out of source control is change management. So with source control, it's all built in. I make a change, I get who made the change, I get what the change was, I get when the change was, and I even get why the change was done. So when you make a change, you put a comment in, and a good practice in source control is to put a comment in that actually means something. I mean, I've seen lots of comments, and I've actually done comments, and we'll probably see them in the demo here, but comments that just are random comments about what the change was and no real relevance. Putting good comments into source control is critical to actually understanding or allowing people to understand what the change was about and not just what files were changed or whatever.
So maybe just saying, I fixed the bug is not a good comment.
Probably not a good comment. So let's talk about kind of the state of the environment now. So before you implement a CI/CD pipeline, what the process is that you go through with that, and then we'll kind of go through what the process is like when you implement the CI/CD pipeline. So typically in the current processes, you decide you want to make a change, you prototype the change in a VM, so you go in there, you manually make the change, or you actually automate the change, so you write a PowerShell script to make the change on a VM. You go test it, make sure that it does what you want it to do, you submit a change form, you go in and take it to a change approval board so that you can discuss and talk about what the change is, why you need the change and all that kind of stuff. You argue about why you need the change, because there's always someone in the change approval board that doesn't like the change. You go through that process and come to a resolution, and then you update the documents on what the change is going to be in production, and you go out and make that change. So what really happens, that is an ideal situation. What really happens is you skip the documentation of that, because documenting things is hard. You don't fill out change forms. All you do is take the change to the change advisory board and argue, and then somehow you figure out what you're going to do. Then you just argue, and you go from there. All right, so what happens in a CI/CD pipeline is you document everything. So Michael went over what configuration as code is, and with configuration as code, you document what the state of the environment should be. So you write scripts, you use DSC, you use Chef to actually, or Puppet to document what the change is going to be. You use source control to check that in and say, this is what it is that I'm changing. One of the second step that you do is you go and pull down the change from the live environment. So assuming you have everything checked in source control, you have one source of truth that's out there. The last deployment you made to production is in change control. So you pull that down to your local environment. You make changes to that. You run your tests locally to say, is this going to do exactly what I expect it to do? And then you push that back out to production so everybody in your environment knows what that change is going to be. And like I mentioned before, it tracks automatically. So I don't need to go update a Word document that says, this is what I'm doing, these are the changes that I'm making, this is why I want to make them. It's all part of source control. So I push that to production, and then anybody that wants to know what the changes are that are happening to the system are part of source control. And last, you merge it to the live environment. All right, so let's jump into a quick demo here. So in our demo, what we're going to show you is we're going to take you through a whole pipeline process from the source control to a dev environment to a production environment. What the change is going to do is actually deploy a DNS server. So we have TFS behind the scenes. We are using DSC and a number of PowerShell tools to actually do the configuration, and we'll take that through the whole process of deploying to a production environment. So we'll use Pester for our testing and some other tools and stuff like that that we'll dig into as well. So the whole point is we have an environment that has a web server out there. We have DNS configured, and we will deploy DNS so that we can go through DNS to this web server that we have deployed in the live environment. All right, so what we have in our code here is basically a project. We have an infra DNS, which is all of the DNS configuration. We have a web app configuration. That's actually not fully implemented right now, but the idea is that in the real world, you could pull in your web app configuration with the DNS configuration, integrate them, and deploy them together so you have the test, the configuration for all of that stuff. With this particular case, we'll just be dealing with the infrastructure or the DNS stuff here. The initiate right here is simply a script that is used to kick off in TFS. Nothing magical about that. The majority of the code is under the DNS section here. And just a couple of things to point out in here. We have tests, the way that this is broken up, and we'll talk about that, the details of this when we get to the test section, but we have different types of tests in here, unit, integration, and acceptance, and we'll go through what those are. In here, we have a couple of Sake scripts, a build Sake, and Sake, how many of you are familiar with what Sake is? Wow, okay, cool, I don't see any hands. So Sake is essentially a task flow tool that's built on top of PowerShell. So it allows you to go in and say, do this, do this, do this, do this. So in this particular case, we're using Sake to generate a PSD1 file. So an environment file, are all of you familiar in DSC with the concept of a structural configuration and an environmental configuration? Raise your hand if you're not. Okay, just a couple of folks. So in DSC, we allow you to basically separate out configuration. So you have the structural configuration that doesn't change between environments and an environmental configuration that will change between environments. That can be a PSD1 file, but it's not, all it is a hash table essentially, so it can be whatever you want it to be. So what this is doing here is generating that PSD1 file for your different environments. And the PSD1 files here are generated from these files in here, so the config environment. So in here, this is actually generating those files. Then the point that I wanted to make with this was a lot of people try to manage those PSD1 files or the environment files as a flat file, and that's not the intent of those things. The intent of the environment file is to be generated from something. In this particular case, I'm doing it from a script. In the real world, people will do it from a CMDB. So they have a CMDB that has all of their environment information. They can use a script to grab that information from there, generate a PSD1 file or the hash file or whatever, and then use that between your environments. So this is just an implementation that we had for a simple case here. So down here, we have two different Sake scripts for deploy. So basically, the build Sake script is all of the tasks that you're going to run in the build process. The deploy dev and deploy prod are two Sake scripts for all of the tasks that I'm going to run for my deployment. So my release process that we'll talk about later on as well. And all of these things, like I was starting to mention before, in build, we generate the environment files, we install modules, we run script analysis, which is, we'll dig into that as well. We run script analysis, do some unit tests, then we compile the configs and have the artifacts that we're going to use as part of the release process. And then the deploy is pretty much the same thing except those steps that we're going to do during the deploy process. And that is all we have there. So this basically, the way that we are working here is we're using TFS behind the scenes. So TFS is already out here. We have deployed a version of this to TFS. We're using Git behind the scenes, the Git protocol, to actually push it out there. So from Visual Studio Code, we can very easily deploy any changes just by checking in a change and then pushing that change to production, and then it's part of our release process, and we can take it from there.
Cool. I want to point out one thing here.
Okay.
We're still on that screen,
Yep.
so that'll work out. Let's go look at the config real quick. So we were talking about declarative configuration. Actually, I'm going to scroll up just a little bit. So notice Mark is acting as a DNS admin right now. He does not have access to the DNS server. So for everybody who's had a security expert say, we really want to separate people and servers. How are we going to do that? And you say, I don't have any idea how we're ever going to get there. This is a process that gets you there. The other thing that's interesting is you see in this configuration, he's saying Windows feature, this is building a DNS server. So Windows feature DNS is going to put DNS on the box. DNS server primary zone. It's going to create contoso.com as a primary zone. And then it's going to for each across A records and CNAME records from that environment data file that he was talking about. So he can go in and make changes, literally create additional DNS records and create new zones. He doesn't have the DNS MMC console loaded up. He's just going back to the script and saying, I need a new A record, name equals IP address. It's just part of my environment data. And now it's stored in that source control. So if he comes back an hour from then and says, oh, I got that IP address wrong, I'm going to change it, just like we do today, before we would go to a CAB meeting, we fill out the form, we document the change, and we argue on that kind of stuff. It's all stored. The whole history is right there. So he could go back in a browser in TFS and say, here's every single change we made, and here's where it came from, and here's the comments about why we made it, and things like that. And he can do it from any machine. VS Code is cross-platform. If you've got IT admins that have VMs running, that they do, so it's a Mac, but they've got VM running Windows so they can open the DNS console and things like that. He's doing all of that without ever having access to the server from any environment in the world. So very different process than what we're used to thinking about.
So by way of example, here's a change that we've already made. You can see all of the changes that have happened to this particular file. This is an environment file. Don't dig too much. Like I mentioned, some of these comments that you're seeing here are not super useful. Fixed bug, not helpful.
I think we got it now.
Yeah.
The one that told me that was fixed.
Yeah. So if you come in here, you can actually see, without doing any extra work, you can see exactly what the changes were between the different versions. In here, this line changed, and you can see exactly what changed here. The comment was added on the right-hand side, so you can see how those changes are there.
So next we're going to talk about builds and what exactly that means. Now this is a more abstract concept to wrap your head around. Because really what we're saying is, what were the ways that in the past I tried to identify there was going to be a problem? So in the process of knowing what I wanted to change, but not yet in the process of delivering the change, just in the process of trying to figure out what was wrong, how quickly did I identify a problem? How did I go through understanding what the regulatory requirements are for my environment and making sure that I met them? So what developers normally think about for build is like, I'm going to take source code and compile it and have an output. In our demo, we're going to do that. We're going to compile a DSC configuration, and our output is going to be a MOF file. But there's more going on here than just that. So let's kind of dig into that. So what do we normally do if we were thinking about how to safely implement a change? Well, we're all familiar with having change windows on weekends because we don't know how our servers are configured when it really comes down to it. The answer we give the business is we do it on the weekend to make sure there's no disruption to the users, right? And the real reason is I have no freaking idea how that server has been configured. It's been running for 10 years. Different people have logged into it. They've made changes. And I'm going to apply this patch, and I'm going to cross my fingers. And I'm going to reboot it, and it might come back up. If it doesn't, I got until Monday morning to fix it. So that's the life that we sign up for when we decide to be IT admins, and we all just kind of accept it and say, yep, that's going to be the deal. So I've lived this experience over and over and over again. Remoted in on Sunday. I used RDC Man because I could dock 150 servers on the side pane. I used to work in operations, and so I've lived this out. And then go ahead and spin them all up, and then just start going machine by machine. Go ahead and get Windows Update open, and then click install. And by the time I get to the bottom, I can go back to the top. Now they're ready for reboots. And like, oh, this one's in a cluster, so it's got to be a rolling reboot. And we just go through it by hand. That's the process that many of us are accustomed to. Mostly this just comes down to that bullet that I mentioned, which is it's hopefully going to come back after I make this change, because if it doesn't, I'm not going to go home. I'm going to stay here until we get it fixed, and that's how we do change windows. So what do we do now? We're going to talk about this in the process of using TFS, Visual Studio Team Foundation Services. There's also the online instance, Visual Studio Team Services or Visual Studio Online. But I want to make the point. Go find what your application teams are using for tools and see if you can work with them. So it might not be the same tools that you're going to see right now. You might find that they're using some other thing for source control, and that they're using Jenkins or Travis or any other build service. And that's fine. People have asked us, well, how would you do this with a Microsoft environment? And that's why we're showing it off at the end-to-end as Microsoft tools. And if you're starting fresh, or if you want to do your own thing, that's a fine way to go implement it. But don't be afraid to go talk to the application owners and say, we're interested in managing our infrastructure using some of your tools. What do you think? And can we get, maybe can we get an account on your tools? You're going to blow their minds whenever you bring that up. But it's an interesting opportunity to collaborate. So in this case,
that's a good point. I mean, all of the things that we're doing here can be plucked out and replaced with other things. We're showing, like Michael said, the end-to-end kind of Microsoft way of doing this, because we've been asked by customers that are using Microsoft technologies, they want to use those tools. So that's what we're showing here. But for TFS, you can pluck out, put in Jenkins. For DSC, you can do Chef or Puppet or any of those other things. So all of these things are very flexible, and this process itself is a big thing to focus on here.
Yep. So for the demo, what we're really going to focus on is what the heck's a build service? I'm going to switch over. Okay, he mentioned before we were looking at code, this tab. So all we've done is slide over to the tab named Build. And I'm going to go to this concept of a build definition. When somebody says build definition, and they say we're going to put a new build definition on the build server, what they're really saying is there's a server somewhere that's going to run stuff. That's all it really means. So if you were to put a build definition and you did a new one and it said, here's an example build definition and it's for creating a Xamarin app, and you say, I don't really understand how I'm going to use this for PowerShell. Whenever I create a new build definition, I choose empty. So I'm not building this to run stuff related to applications. I'm doing this for infrastructure. If I were to say new, and I'll just do this temporarily, and I go to add build steps, if I look under utility, run PowerShell. So my go-to definition for, or my build-to description, or my go-to step in creating a new build definition, this is just going to be a thing that runs PowerShell scripts for me. So whenever somebody first told me this, I said, oh, so this is doing like orchestration. And the guy literally says, you're here from Microsoft, so that's probably what you would say, yeah. And I said, no, I get it. This is just going to run a script, and it's going to go run tests and then go do things. And he said, yeah, this is the way we're using, and so what I gained from that is, this is not a replacement for automation. This is something that can take it from source control to trigger things to happen in automation. So if you were looking at using this hand in hand with something like Azure Automation, you could put your runbooks in here and have it go kick them off, or have it go run tests before they go to Azure Automation. So let's go look at this build definition. In this case, there's my run PowerShell. And when Mark was walking through those scripts, one of them is initiate.ps1. So it's just a clever way that he's starting to wrap the whole process to say, I'm just going to run this initiate.ps1, and it's going to start kicking things off. When he showed the Sake scripts, that's where he's got step-by-step dependencies. Run tests. If the test pass, then you go to the next thing, then go to the next thing. You'll see that the other things that are going on here in this build definition, you see publish test results. He's going to show us tests, but basically we're getting that for free. So if you've heard of Pester, in this case, inside that Sake script, we're running Pester. Pester is kicking out an XML file that says, for all of your tests, these passed, these failed. There are a bunch of open source community tools and products that can take that XML file and make reports out of it. So we're getting it for free. We're having it just, as you're running these, go get the test results, push them back into TFS, and now we can report on it. But you can think about that as If there's lots of tools for that, and I've got tests that can validate my environment, it'd be pretty nice if, when somebody says, hey, is our SharePoint server healthy? If I could trigger a task and it would go evaluate it and then have a nice GUI that reports on it, that's really what we want to start thinking about for collect test results and bring them back. That's why we would do that, so we can do something with them. And then we'll talk about copy files. That's getting ready for deployment.
So just to point out, one of the really powerful things about Sake and this PowerShell script here, this is doing a bunch of different things that in a typical build process would be a bunch of steps here. So you define all of those steps in this particular case in TFS. With the abstraction of that out to a Sake script, you can do this in TFS, and then you can take it somewhere else, and if they're using Jenkins, you can just have Jenkins kick it off. So it doesn't matter what the environment is, you have your flow about, this is how I build this thing, and that can go from whatever environment to whatever environment, which is really, really powerful.
Yeah, an example of that, if I click on repository, it doesn't care that I'm looking at TFS. It's a Git-enabled TFS instance. If I was building this up just as a test lab, you could point this right at a GitHub repo. So it really doesn't care. It's, as long as it can connect to it using one of the known protocols, it's fine. I want to touch on a couple things, and we'll look at test. One is, and this is perfect because I just said GitHub repo, don't put secrets in your source control. So if you've got in your configuration script something that says go build a server, and part of that is set the local administrator password, you don't want to put that password in source control, even if it's part of your local environment. Because then anybody else who comes along in the future and they say, hey, where's the source control? So build that DNS server. I want to build one of those. And then you just gave them your password. Right? So the answer to that is these solutions have ways to handle secrets. In this case, you can store anything that's a constant as a variable and just reference it. So then you can make whatever change you want to your script. And if it's a credential, you can tell it anytime that you reference this, obfuscate it or keep it secret in the database, obfuscate it whenever it comes in the logs, things like that. The other thing, this is the only change I'm going to make, I'm going to turn on continuous integration. Now, that's a big, big topic. There's books on continuous integration and the approaches for that for developer tools. In this case, what I want you to understand about continuous integration, we just told it, when I check into source control, run a build. That's all I told it. So whenever we go back to VS Code and Mark says, I'm going to make a change, and he saves it and he does a push, that build service is going to trigger. And that's all we're really doing by making this change. You can do a lot more with it, but that's what the emphasis going on right now. And the only other thing that I'll mention is it does keep your history. So if anybody wants you to prove, and Mark's going to talk about testing, if anybody wants you to prove, when was the last time that you went back and evaluated the quality of the modules that are doing the work? You can show them. Every single time we make a change, we evaluate the quality. And to make that make sense, we will hand it back over.
All right, so testing tends to be the thing that is most foreign to folks in IT. Yes, you test, but actually defining a document that says, this is what I expect is something that is, I think, most foreign to the IT folks. That is different than kind of dev. So what this is really about is doing just that. How many of you are familiar with Pester or have used? Okay, familiar
Awesome.
with Pester? Okay. How many have used Pester? Okay.
Still awesome.
Yeah, it is very good. So from a PowerShell perspective, Pester is a way of very simply, and I'll show you some examples here in a minute, very simply saying, this is my code that I'm going to run, and this is what my expectation is for that code. What the end result should be, what variables should be going in, what should be coming out, and stuff like that. There are a number of different types of tests, which I'll talk about as well. I have put them into 3 different buckets. Depending on who you talk to, they'll make different buckets and have different definitions for those buckets. But what we used to do before the CI pipeline, from a testing perspective, you would figure out what change you wanted to make. You'd create a VM, you install the OS, you install an app or service, you implement the change. Oop, I will throw this thing on the ground. And that can be done with PowerShell, or it could be done manually. Typically, it's done manually when you're doing tests. And then you try the app out, see, based on your knowledge, you see what it's going to do and make sure that it's what you expect it to do. And then you push a button and move on from there. What really happens in the real world is you don't test. You just go to production like Michael said early on and hope and pray that it works the way that you expect it to work.
Or if you do test, it's something like, yeah, we patched the SharePoint server, and then we loaded the home page. We maybe even went in and opened a document, and then I'm sure it's fine.
Must be fine. All right, so in CI pipeline process, like I was mentioning before, you define a document that says exactly what you expect it to do. You do some lint testing, and lint testing is essentially, it is a way of running through the scripts and making sure you're following best practices. So it's not what the output is of the script or anything like that. It is making sure that you're using variables in the right way and stuff like that. And Microsoft has Script Analyzer, PowerShell Script Analyzer, which has a bunch of Microsoft rules, and you can make custom rules that are for your organization and stuff like that to make sure that everybody is following the same practices in their scripts. There's unit tests, which are essentially checking to make sure that your code that you wrote, whether it's DSC or PowerShell or what have you, is going to do what you expect it to do. So if you create a function, you write a unit test to make sure that that function is going to output what you expect when you input what fixed set of parameters or whatever. So it's really running through and making sure that your code does what you expect it to do. And there are integration tests and what I call acceptance tests. Integration tests, in the definition that I'm using here in this example, is basically making sure that the environment, so when you run a configuration on a machine, that machine is configured the way that you expect. If I set a registry key, I want to make sure that that registry key is set. If I open a firewall port, I'm going to make sure that that firewall port is open. Then you get down to acceptance tests, and that is, I want to make sure that the whole system works the way that I expect it to work. So I have, in this particular example, I install DNS, I set some A records, I set some CNAME records. An acceptance test is not going to make sure that those things are set. It's going to make sure that when I browse, when I go to a browser and browse to this address, I get this web page. So it's not testing the actual settings, that's integration testing. That's making sure that I set these individual settings and stuff like that. So in the demo, so I'll dive in here real quickly. So the test that I started to show before, so pester here real quickly. This is typical syntax for pester. So it gives you a way of grouping your tests. I'll jump down here to the unit tests. So with pester, you give it a describe block, give it a definition of what that group of tests is going to be. In this particular case, these tests are all about the DNS server configuration, so everything inside of the configuration block in DSC. Then you have the configuration script, so some subgrouping of things that you want to test. And then you have specific tests that you want to run and what you expect of those. So it should be a DSC configuration script. So if I run a command, a get command, I want to make sure that that type of function is a configuration function. So it's those types of things that you're looking at in a unit test. So there are a bunch of these tests that you run here. One of the things to point out about unit tests is unit tests should not change the environment at all. When you run these tests, it should not change any settings on the system. It should just be checking your code specifically. So you should be able to run this on any system, anywhere, and it should give you the same results. The integration tests, again, pester syntax here. It does things like I was mentioning before, checks to make sure that the DNS rules are set. So when I configure these things, I expect these ports to be open in here. I expect it not to be blocking traffic. I expect these DNS records to be set. So I want to make sure that I have the right DNS records in my environment. And then last, the acceptance. Acceptance test, like I mentioned, is kind of end-to-end, checking the whole system. And in this particular case, when I am on a system, I want to check to make sure that when I go to test agent 1, that this is the IP address that I get back. not only am I testing that is the way that it's set in DNS, but from a separate system. So in this particular case, this is going to be done from a system that is not the DNS server. So when I'm on that system, when I run, I'm going to resolve this DNS address. This is what I expect to get back. And then it goes all the way down to the web content and stuff like that. When I browse to this particular address, this is what I expect to get back from a page's perspective and stuff like that. All right.
This creates a really awesome check and a balance. So some people look at this and they say, but doesn't DSC do testing? So the process here is DSC built the server. DSC looked at the machine and said, hey, are you a DNS server? Become a DNS server. Okay. This comes back and says, okay, DSC did its thing. Now let's make sure. Do you know who www is? And then it gets an answer, true or false. So this is validating that the environment is now provisioned the way it's supposed to be.
Yeah, and one of the most powerful things with tests is when you run this, it works, and the first time you run, next time you run into an issue, you have a problem that came up that you didn't have tests for. When you make changes to fix that issue in your configuration or your script, add a test that tests it as well, so you know that you'll never run into it again. So let's jump back to TFS here, and I will show you on the build here. When you run build, and this is the same for release as well, every time you run a build, and I'll just go back to a build that we've done in the past, you get results because we have this all tied in the those tasks that Michael was showing you on the published tests and stuff like that. All of the test results show up in TFS, so you can come in here and see in here. So, and just to be clear, what we're doing in build, we run the build, we generate our artifacts, and then we run our unit tests. So the integration and acceptance tests are done after the release, because that's testing stuff that's done when I do the deployment. When you do the build, nothing changed. It just generated your artifacts, so you're just doing the unit test here. So if you come into TFS, you can see in here that all of the unit tests that we ran show up just like they were in the test themselves. So you can see this kind of puts a dot between them, I think. But you have the DNS server configuration should be blah, so you can very easily see what the tests were here. And if any of them fail, you know exactly what that test was that failed, so you can go investigate that. So there's a really good integration here using that output of the NUnit tests here. And I think that was about it from a build and test perspective. We do have tests that we run on the release as well. And over here, they are the unit and integration test, and you get the same type of results here as well. So you can see all of the tests that were run. You get, if you look down here, you can see the types of tests. So because of the way that we set up TFS, you can see these are all my acceptance tests, these are all my integration tests, and these are correlated directly with the tests that we wrote in Pester. So you can really see what failed, if anything failed. All right, I think that's it.
Make sure I turn back on. So we're going to now dig into, we've got the code, we've tested the code, we've run the build. The output of the build was the moth files and scripts that know how to do stuff in the environment. So let's actually make the changes in the environment and do it in a way that we trust and that's safe. And then if I want to do it at Friday at 3 o'clock, it shouldn't cause me to have a panic attack on my drive home, because every time my phone buzzes, I think it might still be broken. So what does it look like to actually make a change in the environment? So what do we do before? And I have heard horror stories about how long it can take in some environments to even get a VM. So this process might actually take a month to 3 months just to get the server so I can make the change in my environment. So I request the changes. Now, if I also need room on the SAN and I need the network to be reconfigured and things like that, this can even take longer. Once I get it, how have we always built servers? So we install the OS, we go through, we go to Server Manager, we add stuff, we might install apps, we configure all kinds of settings. And then because we work in operations, we've got to onboard it into monitoring and patching and make sure we've got a disaster recovery plan and all that kind of stuff. And then we can validate that this seems to do the thing that they told me it's supposed to do. Meaning if it's infrastructure, we probably are the app owners. If it's DNS, I probably am the DNS admin when I build it, so I know what it's supposed to do and I can validate it. But if this is coming from an app team, maybe you work in healthcare and they say, yeah, this just keeps track of patient information. If you can build a server and install it on there, that'd be fine. Oh, good, because I know a lot about how that's supposed to work, right? But you told me it should run and there should be a login screen and then I can give it to you. Well, I got that far, so this looks fine. And then you do the handoff. And we're not really satisfied that we know that it's doing what it's supposed to do, but we did what we were supposed to do. And then we have the go live, which is where we're held accountable for things that we were told to do by the application team. The joke behind this one is that none of them go away. We just live with it. It's once again something that we signed up for when we became IT pros. So how can we look at a better process? We talked before about how the build is just running script from source. We're going to look at running a release from source. Now again, there's a variety of tools out there. We're going to use the tools we've been looking at. There's a variety of partner tools out there from Chef and Octopus and many others that do release management. And once again, find out what your app teams are using and think about how you can be integrated into that process. Mark was just looking at those tests. We're going to look at what does it look like to implement those tests as part of your release. And then the way that you would go into production, and this is the kind of the key pivot that I want to land on here. People look at this and they say, yeah, that whole process, that's really neat for something like a web server when I can just burn it down and redeploy it all the time because there's really no state to that machine. But what about something where it's a shrink-wrapped piece of software, I put it on a server, and I'm just maintaining it over time. I can't wash it out every single time. So then we start looking at the differences between, and you can remember these, continuous deployment versus continuous delivery. So I think about continuous deployment as I can just, as soon as the source code checks out and everything's fine, I can just go to production. My tests look good, just let it automatically go. And really, if I needed to just delete the VM, I could have it back in 5 minutes. So it doesn't matter. It's almost like a workstation that server is so just disposable and I can recreate it. In the case of continuous delivery, which is what we're going to demonstrate here, we're saying I should always have scripts that can rebuild that thing. So I'm not able to just wash it out, but I know all of my changes, I know when they were made, and I'm making incremental changes moving this thing forward. Now, rolling back is not always easy. None of this stuff does magic in the way that says, hey, it's going to be easy to just take a database and put it back the way it was yesterday or change, things like computer passwords still have to be, happening in the background, and we can still step on those pretty easily. But at least it's implementing that process, and as part of your disaster recovery plan, if that server falls over tomorrow, you have the latest version of how that was built at the ready. You don't have to trust that somebody went through a change window and then maybe they updated the build documentation for that server. You know, here in source control, I can look at probably what caused the problem, and I can look at exactly what state that machine is supposed to be in. So it's a continuous state of being ready to redeploy the server. So we're going to switch over to looking at our release definition. So just like that build definition, the same concepts where you create a new one and then you say empty and then you tell it just run PowerShell in this case. So for managing core infrastructure, you'll probably see a lot of that. We are kind of talking to this team about maybe having some example build definitions for infrastructure as we see more people who are using it. In this case, I've actually got two. I've got one for my development environment and one for my production environment. Now this could be anything. In this case, we've got two VMs, both DNS servers, so we can make changes to one. If that looks good, then we can go ahead and make them in the other. So it's kind of like we were saying before, we didn't do testing because it was very expensive. It was a lot of time and things like that. In this case, because it's automated, it's really just happening in the background. It doesn't take you the time to go do the tests. The other thing that's interesting is you could spin up that test VM somewhere else. So if you are taking advantage of a public cloud and you've got something like Azure at your disposal, or in the future, you've got something like Azure Stack where you could provision a test environment and a prod environment as two tenants. There's lots of interesting ways that you could make just disposable lab environments that you spin up quickly, make the test, and shut it back down, and it stops costing you money, and then you're ready to go to production. So we're going to run a release real quick against this environment. I just want to real quick say, For development, you'll see we're running PowerShell, still just running that initiate script. We're just calling out to deploy dev, but we're collecting our test results. So this one is collecting the integration test results. This one's collecting the acceptance test results. This is the one that goes to production. We kind of implemented this as a demo saying, we want to go test in development. If we get a green light from development, then we can manually release it into production. So if you do, maybe your organization's not ready to go all the way in, you could say, well, I can automate from literally I make this change in the source and it goes all the way through testing it on a VM and I've got the green light. Now, my organization says I can't make the change in production until Saturday at 2 o'clock. All I have to do is come back here and hit deploy, and I can feel confident in making that change because all the earlier stuff happens automatically. But we could add steps to this to have it also go validate production, which would make me feel a lot better at the end of that change window.
And TFS does give you the tools as well to do things like scheduling the production on a specific time and stuff like that as well. So we did not dig into that for this particular demo, but it does give you all of that. So if you get to that point, you can do that with approvals and all that kind of stuff as well.
So we've got this set up for continuous deployment, which means if you think about what we did with continuous integration, when you check into source control, go ahead and run a build. Continuous deployment is saying when build succeeds, the unit tests passed, go ahead and run release. And that's what makes it happen all the way through automatically to get to that dev environment. If I go look at history, we can actually go back and look as we were banging our heads at this and making sure it was going to work for today. We can go in and dig in at any one of these. I should be able to get to the logs. Oh, I need to go to releases. So we've got some here that are ready. We could also trigger a new one. But if I go back and look at some that failed, you can see that you get quite a bit of data coming back from the script. Now what's interesting, I don't know if this is a good example of one or not. I can go look at one of those green ones. Yeah, so this one didn't make it far enough for me to show what I want to show. Let's go to the last one, because we know it worked. If I go look at my logs, one of the things that comes up over and over again when we're talking about DSC is, how am I going to keep track of what's going on in my environment? So here's the actual verbose output of DSC as it's making change to that machine. So we've got these two things. I'm going to kick one off in a second, but I just want to kind of go in reverse order. Here's my development environment. These are two different VMs. Here's my production environment. This is saying, step by step, what happened in that dev environment. So I can go back and see exactly the output and the timestamp. It went and got the latest version of the modules. Here comes DSC, so it's saying it needs to have DNS. Did it have it or not? In this case, it already did because it was an incremental change. It needs to have that zone. Contoso.com is present. If we were making changes to an A record or a C record, it's going through that work. I'm looking over here at XDNS record, where it's handling the name records for everything we prescribed. Now here's all the tests. So I can look at those test results in their graphical form, but if I want to see the raw pester output, here's where every single one of those acceptance tests passed. Here's where every single one of the, or that was the integration test. Here's the acceptance test, and then how long it took to run those tests in my dev environment. So if I go back in here, I'm just going to do a manual new release. And we'll go off that last build. I'm going to give it a really verbose name and say create.
Following our own best practices.
That's right. Now when I look at this, what this has really said is, I'm going to take that last build and then trigger those deployment scripts that Mark was looking at in the beginning. Since I'm going to do this manually, I'm going to go first to our development environment. We're just going to assume that I made a change. I could also go back and just add a comment or something to the source control, but I want to save time to look at another situation. So we can see it queuing up and it's in progress.
Logs.
Do it. There we go. It was waiting for the agent to start the output. So this is showing us in real time the output coming back from that virtual machine where the PowerShell script is running. And there's where DSC is going in and validating that everything is still in its correct state. It's the same log we were just looking at. We're just watching it run in real time. So if this was happening because I had made a change in source control, if you went to build, you would see that job queued. You would see your unit tests come back. After that build finishes, you could go to releases. You would see this development task for release queued, and then go run through this. And then you want to have production where that one's waiting for you. And you can say, when I'm ready, I can come back. I can verify everything looked fine when that test run on that test VM. Now I'm ready to deploy to production. Now, this part's very interesting to me as well if you're thinking about a larger organization where, yeah, we're going to go into a change window, but we're trying to figure out how to integrate this process into our existing process. So we're going to go to a change advisory board. We're going to use everything we talked about so far as our evidence that we're safe to make this change and it can be approved. And then maybe they even say, well, once we get to Saturday, what are you going to do exactly? Oh, we're just going to kick that off. Who's going to approve that if you're not the administrator over DNS? Like maybe you've got a team working on this. That whole workflow for approvals and things like that, pre and post. I also want somebody to review this after the change is done that verifies I did my job the way I was supposed to. All those capabilities are here. The other thing I want to show real quick is that the references are all here. So I can see all the way back to that individual commit. Let's kick this off, actually, and then I'll show that in more detail. So this is the same thing. It's just going to run on that second VM. You can see it's in progress. Those references I was talking about, so here's the test results that said everything was fine, that happened in development. So I can go back and show. I'm going to skip that, but I could log in and then go back and show the individual tests. There we go. Deployment of production succeeded as well. If I go back to this build, go ahead and log in so we can show that process. I just want to show that from the release, I can link my way all the way back to the change. So I...
Thank you.
Administrator.
How do you know that's
It's always
not my
either
username?
admin to trader or admin to starter.
Security by obscurity.
That's okay. All I was going to do is show clicking the links to say from the release, you can link to the build. From the build, you can link to source. So now you've got a record. What did you change on Saturday? Well, let me show you the release. That tracks all the way back to source control. Okay, here's the build that says we actually tested the scripts that we're going to run, and we verified that functionally they do what they're supposed to do. We also have a dev lab, then we can show the results of that. This came from this commit. Good, it carried. And that shows line by line, we changed which task we were going. Oh, it changed the order, the hierarchical order of the Sake script. But you can imagine that could be something like I added a CNAME or I removed a host name. I can go all the way back to that line by line change about my environment and tell you that's what we changed on Saturday. Yes, sir.
So would you put your patch management in this as well?
That is an
For something like SCCM, and even if you leave that for SCCM, will it be able to do this kind of validation afterwards?
That is an excellent question, and you have earned a sticker. So I'll repeat the question so everybody can hear it.
Unicorn or
The question
some
is
dinosaur thing?
patch management. What's the right way to integrate patch management into this? There are a variety of answers, and I don't think the industry has settled on one from what I've seen, but here's what I would tell you. The best outcome of any change on that server is whenever I've run all those tests again. So, DNS is an interesting one where I could say, I'm going to test, I'm going to patch the virtual machine where those tests are going to run, and then run those tests again, and now I know that those patches don't break DNS, and then I can go patch production. So ideally, I'm working it through that same pipeline to where nothing goes to production without those tests running. Now, nobody's really settled on how do we want to automate that process. So it could be a runbook, it could be integrating with a service, it could be automating SCCM. So there's a variety of ways that you could do that. You could also just say, I'm going to take those integration and acceptance tests, and maybe patching is out of band from my pipeline, but now I have a good set of tests that tell me things are still working right. So I have not seen anybody settle on, this is a definitive best practice for integrating patch management. I've seen like 5 different answers, and they all come back to, at least we've got the test code that tells us stuff isn't broken now. And we can either run that through the whole pipeline, or we can do it out of band because we've got a patch team and stuff like that, but we're going to arm them with the testing so that we're better off than we were before.
You would see when you have to update the test code from time to time.
Yep.
From patch to patch as well.
Yep, absolutely. So,
They're going to have to go hand in hand either way.
yes, the question is, there's also going to be updates to your test code. And actually, some of those are going to happen from unfortunate situations. So sometimes you're going to make a change, like you might add a CNAME for WWX accidentally, and then you cause an outage because www.contoso.com doesn't work anymore. And then you go to the outage meeting and they say, guys, how are we going to guarantee that we never do this again? And you're like, well, we're human, so we really can't guarantee that we're not going to ever make a mistake again. But what you can say is, well, we're going to add a test, and we're going to make sure that the test says it's www and that there shouldn't be wwx. And then now, whenever it goes to the test machine, it'll check for that. And what we can tell our manager is, we know that won't happen again. Now, I might create wwy. Now, if we have really good tests that's going to go verify, like the acceptance test, this is a bad example because we actually have an acceptance test already that says verify www. But you get the idea. I can say I won't make that error again. Now, I'm human. Something weird's probably going to happen because these are massively complex environments. But I can verify that we've got a plan and a remediation step to prevent that one thing from happening again. You want to take this one?
Sure. So we get questions from customers all the time saying that conceptually that sounds great. We'd love to have this. How do I get started? Like I mentioned earlier, one of the biggest steps you can take is to implement source control. You get a ton of stuff for free with source control. You know, I mean, I've talked to customer after customer that is not using a CI/CD pipeline, and some that are wanting to go there for the simple reason of change control. So they have crashes happen in their environment or issues happen in their environment, and their management says, what the hell happened? And they're like, give me a day, I'll go figure it out and let you know what happened. Where if you have a CI/CD pipeline and you're using source control, or if you're just using source control, you can go look at source control and know exactly what changed. So this happened in the last 24 hours. I can see all of the changes that happened within 24 hours and figure out what changed. As opposed to if I'm using manual processes or using just PowerShell without source control, I don't know what hit this system to cause these changes. Another one is, or a couple other things, don't take it all in at once. Do little things like, as we were building this lab, if you set a CI/CD pipeline for something small, like you get the pipeline set up. Once you have the pipeline set up, adding things to it in an iterative basis is very easy. And we have teams that, or customers that we work with that say that they have a specific project that they're going to work with. It's a greenfield environment or something like that, that they're starting up a new project. That's a great opportunity to implement something like this because you have kind of all kinds of leeway to do that kind of stuff. Another one is tests. That is, like I mentioned early on, that's a hard one for people to swallow. It's the most foreign for people. Knowing what to test and all that kind of stuff. Don't get overwhelmed by that. Just write tests, and then when you come up with issues after that, just add new tests to cover that kind of stuff. So don't worry about writing tests that test everything that you might think possibly would ever happen. So just having tests is a huge step forward, and then continue to add them as you run into issues.
Go ahead.
Okay, sorry. And keep your options open from the perspective of the tooling and stuff like that. We mentioned multiple times today that we're showing you the stuff implemented in this particular way. Don't think that you have to use these tools. Use whatever is most comfortable for you or what is already in your environment. And the tools are just tools. They help you do the practices. The practice of DevOps and doing the CI pipeline is really important as well.
I'm going to show, I had hidden this slide. It's in the slide deck. And it's just a video that I'm going to talk over. But it's what does this look like for a day in the real world? So let's say you're working with developers. They call you up and say, Contoso.com is not working. So what can I do about it? So you open your tools. In this case, you just need a PowerShell session. Clear your local cache. Let's make sure DNS isn't broken. So I'm going to resolve a DNS record that www should be in there. Let's see what happens. Now it resolves to test agent 3, which is in the dev environment, but I don't remember building a test agent 3. So that's interesting. Let's see what test agent 3 really is. Yeah, turns out there is no test agent 3. So name resolution. It's always name resolution. That's always the problem. So
DNS
no
is
problem.
always the problem.
We've pinpointed that. So I go back into TFS. It's exactly what we were just talking about. So I'm going to start at the end and work my way backwards. Let's go to our latest release. This is the last one that went into production. I can see that the deployment succeeded, but one of my tests failed. So I can go back over, and now I've got centralized logging across all of my configuration scripts. But I can also just go back into the test, and the test actually told me, if I dig into it, what went wrong. So the test was expected to find test agent 3. I expected that to match test agent 2. I found test agent 3. If I go back and look at the DSC logs, I can see that DSC did exactly what I told it to do. So expected test agent 3, found test agent 2. In other words, somebody updated the configuration. They said www should equal test agent 3. DSC said, okay, I went and looked, test failed, found test agent 2. This needs to be fixed. I'm going to change that to test agent 3 because that's what the configuration says now. And I can track that all down in the logs by looking at this. So if I hit create bug, right here in TFS I can create a work item so somebody can see it's a known issue, there's an open bug, we're investigating the change, it's assigned to me, here's full details from the deployment logs that explain what's going on. So the bug is out there now. If I go back to build, I can go look at build number 7, because that's what we saw was in the release. And the unit test passed. If I go to the commit, I can see it was requested by Project Collection Service, which means it was run by continuous integration. So let's go back and look. OK, here we can find test agent 2 was changed to test agent 3. That was requested by Mr. Demo at 6:07 a.m. So now I know I can call that person and say, hey, did you mean to change that to test agent 3? You told me that it was broken. That actually broke name resolution. OK, now we got to fix this. So I go back into VS Code. So now we're going to work from source control back out. Here's my CNAME records. There's the broken record, so we're going to point that to the correct A record. I'm just going to save the file. Notice I'm doing all of this from code. I don't need any of the console tools. I've got a local commit, and I'm going to give it a name. Tell it what I'm actually doing. Now I've committed that to the code on my workstation. Now I'm going to push that to TFS. At this point, I can go back into TFS. Oh, I sped up time there. So we're assuming that all that stuff, because it was continuous integration and then continuous deployment, all that stuff ran. And now I can go back in and make sure www does resolve to test agent 2. And then this works for a browser as well. And I've got about 4 different versions of this video that I'm going to put on Channel 9 next week that explain this in a... Yes, sir?
What would actually happen if the DNS administrator quickly change the records? How do you sync up configuration management with what's actually in my environment?
You can't. So let me repeat your question because it's very important, and we should get you a sticker. The question was, What really happens, and you're right, in the real world, is that somebody comes along and says, I'm going to be the hero. I know that this is broken. It's no problem. I'm just going to go to the DNS server and fix it. And you're absolutely right, that happens. The only way to prevent that is if by following this process, we take away access to the server. And we say it has to come from source because that's the only place where our tests are going to run that verify it works before it goes to production. As soon as we allow people, then we start randomizing servers. And his second part of the question was, how do we get that back into the configuration if somebody's randomized it? You really can't. I mean, you can go evaluate it and try to backport those and then kick off the tests and verify that what was implemented doesn't break it, and then everything's going to line up. But it's just invited disaster. And,
which is why
that's
JIT
what
and
we've all been
GIA
living with.
play very well with this process.
Yep.
So using JIT and GIA, you can actually lock down a system, so you can't make changes behind the source control. So it forces people to actually use source control to make those changes, so you don't get that difference.
One thing I would just recommend is that one of the things you can do on the check-in is you can have it require a pull request. That way,
Yes.
someone else in the team can review any changes too.
Yes, excellent point. So his point was there's multiple ways to work with source control, and especially if it's a Git-based source control, you can do that by a pull request, which means maybe somebody from a different team actually wants to manipulate the DNS records, and you're responsible for maintaining DNS, and you're using source control for it. They can actually clone that source control, make the changes that they need, and submit that back to you as a request, and then you can review it. The source control will obviously make that much easier than normal. So as opposed to saying, here's a change review form that says I should have this CNAME pointing here, and let me go look at the console and see what we've got. Now you can line by line see what they've requested and then decide to accept it. And then since you're the application owner for DNS, if you want to think about it that way, your tests have to pass before it can go to production. They might give you additional tests. So they might say, we also have application tests that we want to have pass. And now you're double good. You're saying the infrastructure has to be right and the application has to be right before we go to production. So you can see how this gets compounding and more interesting and more complicated as it goes on. But you're absolutely right. This could be a multi-team effort.
I do have another question.
Sure.
How do you accommodate,
Give that to him.
let's say if I had a case where I'm trying to do infrastructure for a web farm, and in my test, I only want to have,
Sure.
I only want to have 2 web servers in the farm because I don't want to spend all the time to create 20, but when it goes to production, I want to create 20. So how do you
So that's actually where I mentioned early on the abstraction that we have between a structural and environmental configuration in VSC. In the environmental config, you can say, and I can actually show you here real quickly, you can actually say what the name of the servers are or how many servers you want to have in a configuration. So you can separate that out. So here we showed the configuration itself. You can see a bunch of references in here where we have all nodes where in the configuration. So you can actually dynamically build that. So as you go from test to production, you can have that resolve to 2 servers in test, and then when you get to production, that resolves to the 20 servers. So you can dynamically build that configuration that way.
So very,
Apply these same line of thinking to SaaS solutions, specifically
could.
365?
Yeah, actually, well, I'll talk about it and then we'll change the slides, but you could. And the reason you could is you could take any administrative task and put it in source control and then kick it off from build. So if you wanted to say, we could have a run book in Azure Automation that is going to go enable a bunch of staged mailboxes in case of failure. You could store the source for that in source control. It might make sure that the run book is correctly published into Azure Automation and trigger it. Or you could say, I'm going to have some other mechanism trigger it, but we're just going to do all of our testing here. There's a variety of ways you can implement it. But yes, anything that you want to say, I want to take humans out of the equation. And by the way, people hear humans out of the equation, they think, you mean that my job's less valuable. This is a perfect example. If you don't know what CNAMEs and A records are and forward lookup zones, this stuff doesn't do anything for you. So you still have to understand deeply how to manage these systems. This is just a different set of tools and processes that are designed to make it safer to make change. That's the only major change there. So we'll make sure we get stickers on this rail. Yes, sir?
So are you implementing a tester that is part of the
in this case, it's the built-in, right? You didn't go get the latest version of Pester
I did
from
not.
the
It's the
repo.
built-in version of Pester. Yeah.
Yeah.
Yep.
Yeah. I've only got a couple more slides, but the points I want to leave you with, our example for the configuration was dead simple. Add DNS, create a zone, create records. In the real world, you're going to keep adding, probably through composite resources, I need to add a monitoring agent. I need to add a backup agent. I need anti-malware on this thing. So your configurations and your configuration data are going to continue to expand. That's okay. That's a good thing. Take all the stuff that's costing you a lot of time in building and handing off servers, make that your baseline, and figure out ways that you can, through source control, encourage that behavior through the teams. The security team will love you for encouraging other teams and making it easier to make sure that the right agents are on the right machines. There's other tools that allow you through, like you were mentioning for SaaS even, through declarative configuration to control what alerts should fire for this, what rules should be enforced, things like that for monitoring. He mentioned GIA. The thing that I want you to start thinking about is too often we have a team that goes and builds the thing and then a team that goes and runs the thing. This is an opportunity for the team that goes and builds the thing to say, this is what we had in mind on day 90. Like we knew that you were going to have to patch this server. We're not just hiking it over to you and saying, good luck. We're saying, we've tested it. Here's a run book that correctly patches this server. Maybe a service has got to be stopped and some files have got to be copied because there's an application patch and whatever. So you've got the process for that in source control at the time when you go live that says once a month, these 3 things have to be run. Here's the scripts that test the scripts. Have fun, right? It's much, much better than just saying, good luck patching. We hope you enjoy your experience. The other thing that's really interesting is, you saw how many notification type things were built into that tool. Most of these build tools have some way to integrate with notification systems. So it could be send out an email, it could be send an IM, it could be put a line in a Slack channel, it could be anything, it could be send text messages. The more that people are aware that something in the environment changed, the more it will help you in an outage situation. So there are people who have, if they're using Slack as an example, or if they have any given tool where their team is sharing information, that every time one of these runs, it goes and adds a line from a bot and says, DNS changed, DNS changed, DNS changed. And then if the phone rings and somebody says, why DNS change? It's like, yeah, I can see it did. Let me just drill back in and I've got the links to tell me how to do it. So it's just another way of implementing the tools. And the last thing, actually, let you speak to this one if you want to.
Yeah, just this is one of the things that really excites me about this whole process and DevOps and CI/CD pipelines and stuff like that. There are a bunch of community projects out there that really enable the Sake that we talk about is a community project. And it's been built by someone in the community, and it's built using PowerShell, and it's a language on top of PowerShell that is very useful to enable this whole process. Plaster is another one that allows you to kind of templatize or make a common way of setting up a project. So if you have a project that needs to have different tools in it as you get started, Sake allows you to kind of bootstrap that with those tools. Pester is the testing that we talked about here. PoshSpec is a really interesting take on kind of abstracting Pester away. So it's kind of almost a layer on top of Pester. So it allows you to do things like DNS tests and stuff like that in a very succinct way in Pester syntax. And all you need is to install that. OVF is a operational validation framework that automates a lot of testing there. PowerShell, Slack, and then kind of a couple of the there are a bunch of different tools, and just pick the ones that make sense to you that you want to dig into and start working with those. The last two are Lability and PS Deploy. Both of them kind of help in the process of getting the configurations and things like that out to target nodes and doing testing and stuff like that. I've done a lot of work with Lability, and the folks who have done that have done a really creative job of allowing you to run tests with DSC. We have the environmental data file. They kind of extend that and allow you to say, here's my environmental data. I have 5 servers. This is their names. These are their IP addresses. You can use Liability to go click, and it's going to stand up the environments for you. So in Hyper-V, it'll stand up each of the VMs for you, configure them the way that you want them to be configured, and then inject the DSC configuration into there. So it kind of sets the environment up so that you can go and do some tests on it and stuff like that. And PS Deploy does it just in a different way as well. So
That's our last slide with content. On Twitter, I'm at migreen, M-I-G-R-E-E-N-E. You're at Mark Gray, is that correct?
Twitter is MarkG_MSFT.
MarkG_MSFT. So you're welcome to friend us, or follow us, I guess is the correct term. I was about to say friend us on Twitter. We continue to put more information out as we're following down as this wave kind of goes through. But we'll stick around if there's any questions.
Yep.
And thank you very much for staying over time.